the recording if you want to read the word problem, but the basic idea is that there's 3 racers from East High School, and we want to find out the probability that 2 of them come in first and second. Okay, so before we begin, just the basic idea of a probability is the total number we're interested in, total number of events, we could say. That's a little more mathy of a definition. And then we divide by the total number of possible events. Okay, so we want to find out the number of different ways that we could have a first and second place finish. That's the number of events we're interested in. And then we're going to divide by the total number of possible events. So the total number of different ways that these racers could finish the race is 15 factorial, right? Because that's what a factorial helps us do. It tells us the number of different ways of arranging n objects. So the total number of events we're interested in, this is where we could try to make a little numbering system, little lettering system to help us figure this out. Let's say A, B, and C are the names of our racers, and then D, E, F, all the way up to 15 are the other racers. This would be an arrangement where we have a first and second place finish, right? This would be an arrangement where our team has first and second place. Let's see. Let's stick with A, actually. Let me back this up. We could have AB, we could have AC, we could have BA, we could have BC, we could have CA, or we could have CB, and I think that's all the different combinations. Okay, so there's 6 different ways that R3 could come in the top place here, the top 2 places. But then look, when you try to make these arrangements, where does the other letter go? B could go way back here, then this could be D, E, F, or this could be, the arrangement of the other 15 could be different. This could be E, G, all the other 15. There's lots of different ways of jumbling these up too. So what we need to do is we need to take the 6 different ways that we could arrange R3 and get a top 2 place finish, and then multiply it by 13 factorial, because this is where we've selected 2 of the racers. There's 13 other whose order we don't care about. We need to multiply it by the number of different ways those 13 other orderings could happen. Okay. Once as a simplified fraction. So to simplify this fraction, could expand the bottom. But I know setting up the problem is the hardest part. I know a lot of us are good with making those calculations. The real question is setting them up. So we got 15 times 14, 210. Does 6 fit in evenly? Yeah. I should have done that. 1 over 35 for this one. Okay.